section 9.3, we are going to be multiplying binomials. So there are two goals today. First goal is to multiply two binomials, and then the second goal will be to multiply a binomial with a trinomial. So if you noticed, in the first example, I have a binomial with another binomial. We're going to multiply those two together. And the way we describe this is we're going to do what's called a FOIL. We use an acronym FOIL to describe the method of multiplying binomials. So if you notice this right here by itself, this is the first term and then this is the last term. First term, last term. Together, these two on the outside called the outer terms and the ones on the inside called the inner terms. So like just distributing, we're going to take the 2x and we're going to distribute. So we're going to distribute that, and that will be our first term because those are the first of the both binomials. And then we're going to do the distribute it again, but then together these are called our outer terms. So we distribute those. So then we got our first, right? First. And then we have our outer. And then we have what's called the inner, because we're going to take this second term over here and we're going to distribute those in also. So this will be my inner, and then we're going to distribute it again. That will be our last. And that will be our last term. So now when we FOIL, we do the 2x times x is 2x squared, and then 2x times negative 2 will be minus 4x, and then negative 3 times x will be minus 3x, and then negative 3 times negative 2 makes it a plus 6. So first, outer, inner, last. And then if you notice, the middle two terms are my like terms. So most of the time, those two will always be my like terms. So now when we simplify it, we get 2x squared, negative 4x minus 3x makes it a 7x plus 6. And that's how you multiply binomials using FOIL, or we call it distributing. But FOIL, or foiling, is a verb that we use to describe multiplying two binomials. So we're going to try one more here. We're going to do first, so 4x times 3x is 12x squared. 4x times 6 is negative 24x. And then 2 times 3x is plus 6x. And 2 times negative 6 is minus 12. And these two, like again, those are my like terms, so which makes it 12x squared minus 18x, so negative 24 plus 6 makes it a negative 18x minus 12, and we multiply those together, and that's what you get. Okay, so FOIL. So now, and we're going to apply this to finding the area that's shaded. So we're looking for the shaded region. Well, to find the area of a rectangle, I have a big rectangle and a small rectangle. Area of a rectangle is length times width. So we're going to find the area of the big one, big rectangle. Okay, the dimensions for this one is 3x plus 2, and we get 2x minus 1. Okay, and then the small rectangle would be x times x plus 3. So what we're going to do is we're going to find the area of the big one, and then we're going to find the area of the small one, and if you subtract those two areas together, what we would get would be the area of the region that's shaded. So now we're going to FOIL again. 3x times 2x is 6x squared. 3x times minus 1 makes it negative 3x. And then we got 2 times 2x is plus 4x, and 2 times negative 1 makes it a minus 2. And like we did before, those are like terms, so we get 6x squared plus x minus 2. And this is the area of the bigger rectangle. Now let's find the area of the small rectangle. So if you notice, I get x times x is x squared, and x times 3 is 3x, and this is the area of the small rectangle. So what we're going to do is we're going to take those two areas, and then area of shaded region is the big minus the small, big minus small, which then becomes 6x squared minus plus x minus 2, and we're going to subtract x squared plus 3x. So remember from section 1, when we're adding and subtracting polynomials, we have to, when we subtract, we have to distribute the negatives in. So this becomes 6x squared plus x minus 2, and then when we distribute that in, that becomes a negative x squared minus 3x. And if you notice, 6x minus x, right? Those are my like terms, so this becomes 5x squared, and then I got x and minus 3x makes it a negative 2x minus 2 is what's left, and this right here is the area of the shaded region. So find the area of the big rectangle, find the area of the small rectangle. You take the big minus the small. Don't forget to distribute the negatives in, and then you combine like terms, and that's how you get the area of the shaded region. Okay, so that's how we use multiplying binomials. Now, the last goal we did was to multiply binomials with a trinomial. So in example number 4, we have a binomial and a trinomial. So we're just going to distribute like we did the other one. So we're going to take the 2x and we're going to distribute. So 2x times 3x squared is 6x to the third. Remember, you add exponents when you're multiplying. And then we got 2x times negative 2x, which makes it a negative 4x times x is x squared. And then 2x times 3 makes it a plus 6x. Okay, so you did the first term. Now let's do the second. 7x. 7 times 3x squared is plus 21x squared, and 7 times negative 2 is negative 14x, and 7 times 3 is plus 21. Now we're going to combine like terms and put it in standard form. So my highest exponent is 6x cubed, and the next ones are negative 4x plus 21x squared, which makes it positive 17x squared, and then I got 6x minus 14x makes it a minus 8x, and what's left is plus 21, and that will be my final answer of multiplying binomials with a trinomial. So it's like distributing still, and that is section 9.3.